So today we're going to talk about one-sided limits, and what's going to happen is the bookwork that I have on today is actually not due until Thursday, okay? The bookwork I assign you today is probably what you want to save for after the quiz tomorrow, okay? The worksheet we'll do in class, and the review I give you tonight should be enough practice for what will be on the quiz tomorrow from this lesson. Okay? So, notation. We love notation. We have right and left hand limits now. Okay? So, just stop writing for a second so I can point something out. Do you see how these have superscripts of either a minus or a plus? This means we're approaching 2 from the left side, from the negative side, left. This means we're approaching 2 from the right side. Write down what you need to. Okay, the first thing you're going to need to be able to do on the quiz tomorrow is look at a graph and figure out right and left hand limits. Okay, so I'm going to go to a picture of a graph and I want you to draw it. It doesn't have to be beautiful, but I want you to draw it so you have it to reference. Okay, and we're going to talk about some left and right hand limits. Okay, the first limit I want to look at is the limit as x approaches -1 from the right. That little plus sign means we're approaching it from the right. So here is x is -1. If we approach from the right side, what y coordinate are we approaching? We're approaching 1. Okay, so the limit as x approaches -1 from the right is 1. The limit as x approaches -1 from the left If we approach negative 1 from the left side, we're up here. What y coordinate are we approaching? 2. So from the right side, we are approaching 1. From the left side, we are approaching 2. What could we say about the limit as x approaches negative 1? It doesn't exist because our right and left hand limits are different. The limit towards just negative 1 is not going to exist. Okay, so we're going to work on, we're going to answer 3. The limit as x approaches 2 from the left. The limit as x approaches 1 from the left. And I'll put it over here, the limit as x approaches negative 3 from the right. I'll give you 60 seconds to consider those. Okay, Ashley, what do you think about the limit as x approaches 2 from the left? It would be 2. Okay? I wanted to make sure you understand that even if there isn't a break, we can look at the right and left hand limits separately. Okay? The limit as x approaches 1 from the left. Trevor, what do you think? Doubtful. What does this negative superscript mean? From the left. Here is 1. Why would it be due me? There's nothing on the left side. Would you say that this piece of the function is on the left of 1? Okay, so what y value are we approaching? 3. From the left, we're approaching 3. From the right, we'd be approaching 1, which means the limit as x approaches 1 would not exist. Okay? All right, and how about the limit as x approaches negative 3 from the right? Amy? 1. Okay? This is going to have a right-hand limit, but it's not going to have a left-hand limit because it's the end. Okay? Questions on graphical right and left-hand limits? Okay. Please write down this function. This is the second thing from today you'll see on the quiz tomorrow. Bless you. And I'm going to ask us to talk about the limit as x approaches 0 of h of x. Why do you think I chose the limit as x approaches 0?
Because that's the only part where the two functions don't necessarily include it, but that's where the question starts.
Okay, that's like our break in the domain, right? One function is all to the left of 0, one function is all to the right of 0, okay? So in order for that limit to exist, we have to ensure that the right and left-hand limit are the same, okay? Now, x plus 1, that is all to the left of 0. X squared plus 1 is all to the right of 0. So we need to look at the right and left-hand limits separately and see if they are the same. Okay? Hi. Okay. So, anytime you're asked to find a limit of a piecewise function at the break in the domain, you have to look at a right-hand and left-hand limit. If I asked you for the limit towards 1, not a problem. You would just use direct substitution and plug it into x squared plus 1. But since we're at 0, and that's where the domain breaks, we have to look at left and right-hand limits. So, the limit as x approaches 0 from the left of h of x. Which function is to the left of 0? X plus 1. So that means we're going to use direct substitution with x plus 1. Which we get 1. Then we're going to look at the right-hand limit. Okay. What function is to the right of 0? X squared plus 1. So we're going to use direct substitution with x squared plus 1. We get? Now, do our right and left hand limits match? They do. Since they both are 1, then the limit as x approaches 0 is 1. Now, tomorrow on the quiz, you do not get full credit for saying 1. You get full credit for showing me right and left hand limits both equaling 1. Making the limit 1. Okay? Let's look at the graph and see why that is. Okay? Our two pieces are meeting, they're overlapping at the coordinate 0, 1, which is why our limit is 1. Okay? So our half of a parabola and our half of a line are meeting right there, which is why the limit exists. Okay? Let's look at a second example. Okay, do you remember, it might have been the very first day we started limits, I said, hey, remember this graph? And it was the absolute value of x over x. What does it look like? What actually the answer for that? Good. Looks like that. So let's talk about the absolute value of x minus 5 all over x minus 5. Transformations. This graph, but what? To the right 5. Okay? So, if we're talking about the limit as x approaches 5, well, you have a break, right? Oh, let's make that f of x. What's the limit as we approach 5 from the left? What is the limit as we approach 5 from the right? Are those the same? Which means the limit doesn't exist. Okay? That is a graph I expect you to be able to think about. You can draw it if you would like. Okay? But you need to be able to think about this graph and shift it left or right. Okay. You and your pod need to find me the limit as x approaches 1 of this piecewise function. And then we're going to move on to an in-class worksheet. I will give you and your pod 2 minutes to complete this problem. Give me a thumbs up if you need more time. Okay. Brett, what'd you do first?
I put the limit of x to 1, and then the to the left, so like a negative.
Okay.
And then f of x equals x cubed plus 1.
Okay, so you plugged 1 into x cubed plus 1.
Yep.
Do you agree with Brett's first step? From the left, we have x cubed plus 1. So we plugged 1 into x cubed plus 1. Okay? So far, so good. Let's see, Will, second step.
I plugged 1 into x plus 1.
Okay. Did you write the limit as x approaches 1 from the right before you did that? Okay. I do need to see a limit. I can't just see you plug in numbers. Okay, this has to be some calculus proof, all right? So then you plug to the right of 1, you said it's x plus 1? Okay. So what can we conclude? The limit as x approaches 1 is 2. If these were different, you would tell me it does not exist. Okay? I'm glad Will brought that up, though. Tomorrow, I have to see limits, right hand and left hand. Otherwise, you do not get full credit. Now, would I need to see a right and left hand limit if I ask you for the limit as x approaches 5 on this problem? No, because 5 is not a break in the domain. You can just pick which one to plug it into. But 1 is a break in the domain. That's when you have to do the 2 different limits. Okay? All right, I am going to give you and your pod about 5 minutes to go through this graph worksheet. Okay? A good portion of your quiz tomorrow is going to be evaluating limits graphically, and so I want to make sure before you leave you have that nailed down. If you're watching from home, this limits using graphs worksheet is attached to my website. All right, here are the answers to 1 through 8. Did you, I know Pod 3 was uncomfortable with so many 2s, like maybe we're doing something wrong.
So there were too many.
There are too many. Too many. Okay, questions on 1 through 8? Yes, you were stretching. Okay. Good? All right, 9 through 18. Is that a happy dance, Will?
Yeah.
Good. Questions on some of these? Any of these? One of these? None of these? Okay, Pod 6, I see you fixing in answers or something I can clarify.
How is 14?
The limit as x approaches -4. So if we follow the curve, we're approaching this hole, which is at 2. From both sides, our graph approaches that hole.
So we can just disregard it.
That is the function value. So if I asked you for f of negative, or excuse me, g of -4, you would tell me 0.
Oh,
Let's see, tomorrow? Or, yeah, tomorrow we'll talk about what it means when the hole and the dot are at different places. Okay. Not tomorrow, Thursday. Thursday. Feels like Wednesday to me. I don't know. All right. And the last chunk. Questions here? Okay, so I would like to point out that this is a college level class, right? You have 2 different opportunities to receive college credit, whether you dual enroll or you take the AP test. And so I'm going to treat you not completely like you would be in college, okay? But my expectations are a little higher for you, okay? So we have a quiz tomorrow, and we didn't have an all-day review like maybe you're used to, okay? That's okay. You need to be able to be comfortable with that, okay? Sometimes we will have all-day reviews for a quiz. Sometimes we will not, okay? Now, what I'd like to point out, if you have your gold sheet available, on the back of your gold sheet are objectives. Okay, so I just want to point out what objectives are going to be covered on the quiz tomorrow. Your review should give you a nice variety of problems, okay? But our quiz is going to cover section 2 and section 3. Hold on. Okay. Our quiz is going to cover sections 1, 2, and 3, and then just the right and left-hand limits from section 4. The rest we're going to talk about on Thursday. Okay? With this left and right-hand limits analytically, that would be like the piecewise function that you did, okay? And then graphically, that's what we just did on that pink sheet, okay? So if you want to just take the next couple minutes, you're not going to start your review right now. Just take the last 2 minutes of class and evaluate yourself on this gold sheet. Leave room because we'll do this again. You're going to evaluate yourself more than once on these objectives. So just on the objectives from 1.2, 1.3, and these two on 1.4, tell me whether you feel like you could teach it. That's a 4 all the way to 1. Yikes, I have a lot of questions. Okay? After you do your review, maybe reevaluate yourself again and figure out whether you need to come see me before first hour tomorrow.